Thanks for returning timely to this talk. I bet that you are quite worried about what's going to happen to your staple rice in the next decades. Okay, so that's what we're going to talk about. Quickly here, we're focusing on southern part of Vietnam, to be exact, the Mekong River Delta. Okay, so that's number one. Number two, you will see later on why we are trying to look into this particular domain, Mekong River Delta, first of all, Vietnam in general, Mekong River Delta in particular, because that's really this where we import our rice quite a bit. 1/3 of the rice from Singapore is coming from there. Okay, all right. Now this is in collaboration with the various folks. Can Tho University, which is an agriculture university in Vietnam, so they have the domain expert in the agriculture side, and then together with the Asia Risk Center. Okay. Now, of course, collaboration with Chien Wang and Chien Wang's team. Now, these are the names of the folks working in this particular project, so that's quite a number of people. I will not name them one by one. All right, so the background, the outline of the presentation, essentially I will be referring a little bit the background of why we are choosing that particular area. Okay, and then since we're dealing with the future, the climate change impact will come into picture, of course. Okay, that's the reason. The second one is a climate model projection. And then, of course, the focus of the study is nothing but the crop model, and then the results. After that, we are looking into, don't forget that we are looking only the 2020 to 2050, just the next 30 years, and so on and so forth. Can the future work or the ongoing or the future work, and come with the conclusions. Okay, this statistic over here on this particular slide is quite relevant. Number one, rice cultivated in this particular area, the Mekong River Delta, is about the yield, the rice yield from this particular area amounts to about 55% of the entire Vietnam's cultivated the rice yield. Okay, so remember 55% roughly, and the rice yield from this is about from Singapore side, from Vietnam side when they export, 90% of that coming from this Mekong River Delta. All right, now Singapore being a country importing almost everything, 90%. Now 30% roughly, there are three big countries, India, Thailand, and Vietnam. Roughly about each one of them is about 30%. So we're importing from these three countries roughly 30, and 30%. Okay, so that's the reason I think of the concern to Singapore is what to expect the crop yield from the exporting country, these three major guys. Okay, so and then strategic planning perhaps to what to do next. All right, now what you see over here on oops, what happened? Okay, now this particular drawing here, this drawing is nothing but the Mekong River basins, all the way from China side, Myanmar, you name it, the other four countries. And of course, at the bottom end of it is nothing but Vietnam. Now, what we are looking at, the domain, the region, the Mekong River Delta of Vietnam is nothing but here, enlarged there. But again, we are focusing only on this particular region, which is about 5% of the entire Mekong River Delta. The name is Hau Giang. Okay, so 5% represented this particular Mekong River Delta of Vietnam. Now, what is interesting to remember is that the following, although there is 5%, it is also 5% of the productivity of the rice yield from the entire Mekong River Delta. So roughly, there you go, 5%. Okay, so later on, the conclusion from the study for the projection, we will just multiply for now 5% of that, then we multiply by 20 times. That's it for now. Okay. And particularly of interest also to see that the yield, the productivity itself is similar of the entire things, about 5 tons per hectare. So that could be a good representative of the study. Okay. Now here, the rice yield, you just ignore all the pictures there, except this two solid line, the blue line and the red line. These two lines are nothing but the rice yield. What is interesting to note is not that this is coming from one particular season, that is a winter, spring time. The other one is summer. Now, the reason being winter time is much more productive is because this reason. Number one, the rain is very heavy during the summertime, so hence you destroy some of the plant. And the other one is the pollination. Of course, that's what it means. The pollination is destroyed, more pollination destroyed. And the other one is that during the summertime, you have more pests, obviously. You have more pests, okay? And then at the same time, also during the winter time, the area cultivated, in principle, is smaller than during the summertime. Okay? So for this reason, hence the yield from the summertime here is less than the one from the winter. Okay? Now, quickly over here is the observed values for the last 35 years. Okay? Now, the question right now is, how are we doing with the climate? Are we having less precipitation? Because that's the ingredient for the planting in the first place anyway. Okay, so now, again, that may not be long enough to of course, the last 2 years is nothing but El Nino time. Everybody knows that it's going to be less rainfall. It's already being witnessed anyway, but the question is whether the trend is going to be less rainfall. You will see later on the projection from the downscaling work. Okay, so now, what is important for crop model as again, beside the soil, also the weather. The weather over here, what is needed is nothing but, number one, of course, precipitation, temperature, the number of hours of sunshine, duration, is in other words, and humidity and wind. These are the 5 major parameters required for crop model, aside from other things. Soil, of course, obviously, too. Yeah? In the management of the crop, too. Now, since we're talking about the projection for the future of 30 years, a quick commercial over here. This is what the team, Tropical Marine Science Institute, working for the government of Singapore, doing the climate change projection for the next until the year 2100. Now, what we did, the commission work by the government of Singapore, we're looking into the 3 GCM, the American one, CCSM, Max Planck, and then the Japanese MEROC. Okay, so now looking at that, again, the emission scenario, we look into the 3 emission scenario. So, but here I'm trying to highlight to you that the result of the study today, we are using uniformly A2, A2, A2 emission scenario from all these 3, so that the result can be better, has more credential using the same emission scenario. Comparison is much better too. Okay, so of course the model we use, never mind about it. Okay, now what you see over here, just quickly on the top 2 pictures, is nothing but the temperature changes with time all the way to the year 2100. A2 scenario, the WRF driven by ECAM in this case, just to demonstrate. On the left-hand side, the temperature. On the right-hand side, it's nothing but the precipitation. Now, what is interesting over here? Okay, look. First of all, I think look at this one first. The maximum and the minimum temperature in the next 90 years is going to be increasing. Everybody knows about it. But now, what is interesting for crop is this one as well. Now, if you see over here, the red line is nothing but the mean precipitation throughout the whole until the year 2100. Now, what you see the next 40 years, 30 years or 40 years until 2050, the mean rainfall in principle is less than the mean of the the entire century. Okay, so that alarm us a little bit about whether our crop yield is going to be affected seriously. Okay, so take note on that. So less than the mean. All right, so this is again the result from our work with commissioned by the government of Singapore. So again, as usual, simulated. You have to compare it with the observed data. So the observed data I'm showing you only for this particular particular presentation is the CRU, Climatic Research Unit of East Anglia University. So temperature, in principle, is not too difficult to get it right. And the same thing also with the wind direction for entire Southeast Asia. They are pretty good, as a matter of fact. Again, northeast monsoon, observed versus simulated. Okay? Again, wind is not a big issue, not too difficult to get it right. And then next thing would be southwest monsoon, JJA, June, July, August. So again, they look pretty similar to each other. Now, of course, the most nasty parameter is nothing but the precipitation. They look definitely they look different in many places, but again, which I don't show here, we use all the gridded observed data from 7, like CRU, UDEL, and so on and so forth, plotted. They themselves differ from each other. Okay, so that's the precipitation, daily precipitation that is. Now, take note on this when we say about observed, make sure we all know that this part of the world, the data is not that great for sure, particularly when you're dealing with many years ago. Okay, all right, so the next few slides, essentially I already mentioned about it. So the temperature, the increase for the next 30 years is by this year, and then a minimum temperature as well. So we have that already. I skipped that. Now, the monthly mean temperature, again, okay, roughly is about 36 degrees for the maximum temperature. The minimum is about 28 degrees. Okay, both are increasing, obviously. Now, take note of the precipitation here. The precipitation in Hougang, or Mekong River Delta, it has two peaks. Okay? So the dip is about in the month of August. So we have two peaks, and then now with that, now the crop modeling side, as usual, you have to do calibration of the model, validation, and then run your future scenario. Okay? Now, these are the four components of importance is nothing but this here. The weather, we got it, observation data coming from the Vietnam side, and the cultivar, fragrant rice, is the one we are working on. Okay? And the soil is nothing but of the riverine fluvial soil. Okay? This is all from the sampling. The Vietnamese team did that. Okay? With that, then obviously, then later on you have to do the validation using, again, whatever we have calibrate on this, check on the yield, and finally use the climate projection from the study commissioned by the government of Singapore at this point in time. So we run that to look at what would be the crop yield in the next 30 years. All right, quickly over here to flip, we have roughly about 9 parameters to calibrate from the crop, the DS set, Decision Support System for Agriculture Transfer, DS set. Now, and then after that, obviously, when you calibrate, what you're interested in is nothing but to look at these particular 4 parameters, whether they match with each other, simulated versus measured, and so on and so forth. So one of them is nothing but your yield. Yeah. So, and then after that, you do the same thing again with the different events and looking at the yield, whether they are quite close to each other. Okay. So the technique is similar to whatever crop the modeling side. Now, this is what the highlight of the whole thing: the yield for the spring, winter, spring, and this is summer and fall. Now, again, this is to be compared from the projection and the current observed value of the yield. Okay, so the summertime and the springtime. Now, this is again coming from all the GCM, the one I mentioned before, CCSM, ECAM, and MIROC. Now, here, for the future, now with respect to the last 10 years, 2004, 2014 yield. So what you see over here, this is on the decadal presentation. The first 10 years, the second 10 years, and the third 10 years. 2020, 2030, 2030, 2040, 40 to 50, whatever, okay? Now, the yield is going to be this is the WRF driven by CCSM though, yep. About 30% less, 25% less, 36% less. Now, this is totally depending on rain only, the rain fed. Okay? Now, if you help that with the irrigation, obviously that's a common sense. You will get more data, more water coming from somewhere else, irrigation. So you will improve the yield, of course. Yeah? Now, next, I'll flip that quickly over here. This is WAF driven by ECHEM, WAF driven by Maroc. In principle, the look is similar to the one over there. You have much less, the yield is reduced significantly from WAF driven by ECHEM, WAF driven by Maroc, the same thing too. Irrigation help to give higher yield, obviously. Okay? Now, all in all, having done that, just for the winter, springtime, you have a reduction of about 24%. Okay, from that particular Hougang area. Now, similarly, without saying too much about it, similar plotting. Now, same thing again for the summer, autumn, summer, fall season. So again, quite serious over here, that over there. Yeah, the tree model. And the message is that you may have about 49% less during the summer, autumn season overall. Okay? Now, all in all, before winter and summer together is about 35% in average, to be expected, to be anticipated rather. Okay, all right, so with that said, the future work, I have only 2 more slides. The future work, we try to see the crop yield from the other part of the Mekong River Delta, because it was only from Hougang being scaled up, the result being scaled up to the whole Mekong River Delta, but we will pick up another sites in the Mekong River Delta, plus a few more major cultivated area, rice cultivated area in Vietnam, which is the Red River Delta, obviously. That amounts to about 15%, and plus the other thing is central north and central south of the coast. Those two each contribute about 15% or so. All in all, 55% for Mekong River, 15 and 15, so you're talking about 84% of the cultivated the rice yield coming from this area, the one we had in mind. After that, what we do, we will work on with Thailand and again India, as you know by now, 30%, 30%, 30% coming from these 3 countries. For Singapore is importing from these 3 countries. Lastly, we will look into, again, some vegetable, perhaps cabbage, so survival of the fittest. So at least you should have something, a staple, rice, for instance, and something, just one vegetable, perhaps in this case, cabbage or tomatoes. Okay? So at least try to survive, first of all, for Singapore side. And finally, what we have in mind, this is a downstream end of it, the whole thing, trying to develop what is called the serious games. That essentially, when we have, of course, we have to work together with somebody to develop the engine. Okay? Now, developing the serious games, in principle, is trying to use that for the educational purposes and introduction of climate projection, climate change part, and the crop yield to the school and public. Okay? So finally, the conclusion is, how I said it before, rain-fed, quite obvious, rain-fed rice yield definitely is going to be less productive than the irrigated one, with obvious reason. But the problem is, that's about 35%, right? The reduction. Now, this one irrigation, as we said before, certainly will help. The question is, or the challenge rather, where do you get the water from? The whole area is going to be less rainfall, so that's good. That's a challenge, how to bring those excess water from somewhere else to this part for irrigation. Now, finally, for Singapore side, given 90% of the rice coming from the Mekong River Delta, and then Singapore total import from Vietnam is about 30%. The rice yield is going to be 35% less in the next 30 years. So the question is, this is perhaps the information could be useful for AVA. The AVA is agri-food veterinary agency of Singapore, AVA. Okay, so that could be useful for AVA. Thank you very much for your attention.
Yeah, thank you. Very much interesting study. But I have 2 questions. One is that how much area in the Mekong Delta is irrigated now? And And the second one is that rather than the decadal mean average crop yield, but the fluctuation matters for the food security. So that the mean yield could be lower, then you can import from anywhere, other place in the world. However, that sudden extreme weather and decrease of the crop yield may have some serious situation in the food security.
Okay, the first one on the area irrigated. In principle, from our reading, we actually depending on one of the Vietnamese interns, because they have to Google it in Vietnamese. Otherwise, you won't get that information. Roughly, but at the moment, it's about 40% only.
Only
40, yeah, because it is an engineering work. Okay, so man-made introduction things. Number two, on the fluctuation, within the next 30 years. Well, I thought you have the average of the mean of the entire 90 years. We want to see the mean of the next 30 years. Where is it? Okay, so that's the reason that line is quite important to us to see whether that makes sense also to link that plot with the results. Yeah. Okay. Thank you.
Any more questions?
Wolfgang. Yeah.
Looked as if the second decade was better than the first one.
Yeah.
Is this because you use only one realization and not an ensemble?
Correct. No, it's better because of the rain is slightly more, the second decade. Similarly, I did not mention about
Yes,
it.
but that is because you use one realization. If you had a whole ensemble, then maybe this effect is gone.
But you see, well, you saw the result is being shown on each individual GCM. So this 35% is an ensemble of the three.
Of the three,
Yeah, it is ensemble of the three. Yeah.
Thanks, Yuri.
Thank you.